So I'm gonna press.
Hi everyone. Come on. Here. Hi everyone. Here with me is Christian Barra, an entrepreneur from Berlin. Sorry for being a little bit late. It's still 10 minutes only. And Christian will talk about the WebSockets and webhooks done right. So I'm switching us to the this layout, and I'm switching me off. Christian, the stage is yours. Oops.
So hello and thanks for having me here. My name is Christian, and today I'd like to talk about WebSockets and webhooks done almost right. So before starting, a little bit more about myself. I'm based in Berlin. I'm a tech lead at a Team Farm. It's a vertical farming company, and what we do is we grow food, herbs with software. I'm a Python Software Foundation Fellow, and I run PyBootcamp, which is a training and consulting company on Python and DevOps. So this is today's agenda. I'd like to talk about why you would need to use webhooks or WebSockets. I want to dig a little bit more on webhooks, how you can implement them in Python, and then I want to do the same with WebSockets. And I want to share some code snippets that you can probably use. And before leaving, I have some goodbye tips, and a few notes or advices that you can probably use. So why do you need WebSockets or webhooks? WebSockets and webhooks, they are fulfilling different needs. If we talk about webhooks, for example, you want to be updated as soon as something happens. So you can think about webhooks like a sort of callback. While for WebSockets, the use case is completely different. You probably want to use WebSockets when you want to have a low latency bidirectional channel. If you want to stream data in both senses from the server and from the user. And we can think about some real life example. If you open a web browser, if you open a Twitter, if you open Twitter on your web browser, you will probably receive tweet from someone you follow, like updates. If you think about receiving a notification for a Slack message or a notification for a new pull request, or you want to be notified when your CI/CD deployed master to production, or an example coming from the Stripe API is when a credit card is charged. And if you think about Facebook, Telegram, and WhatsApp, their chat implementation is a good example, is a good use case for a WebSocket. Although probably under the hood they use different technology. But WebSockets perfectly fits the need for I need to create a chat and I need to broadcast messages. So let's start with the webhooks. Webhooks is not really a technology. It's more like a way of doing things. It's more like callback for the World Wide Web. So you don't have a specification. You don't have like a standard. But it's pretty much the most common way to connect and to notify different APIs about something. And for sure, you have two different kinds of webhooks. You have incoming webhooks and you have outgoing webhooks. And well, the difference is quite simple. Incoming webhooks are webhooks that your service is receiving, so your service is notified that something happened. And with outgoing webhooks, your service notifies other services, other APIs that something happened inside your system. And now we can check together a webhooks implementation in Python. So we can start from the outgoing webhook. And this is pretty much a good starting point to implement an outgoing webhook. An outgoing webhook at the end is is a client request to an API endpoint. If you're not familiar with the async syntax, don't worry. The implementation, you can pretty much compare the implementation with a synchronous one. So here we define a call webhook function. This function has 3 arguments: body, ID, and URL. We create a signature. I'm going to explain later why we need a signature. Then we have some headers. We pass ID, we have a signature, and we have a timestamp. So these 3 things are really important. First of all, we want to have a unique identifier for the webhook. Each request should be unique. And then we have a signature, which is a way to the receiver, for the receiver, to verify that the request comes from a trusted party. So there is a secret. If you see on line 3, to make signature, we pass a secret, and this secret is shared among us and among the receiver. So we are encrypting the payload using the secret, and we pass the payload inside the header. Then, because the receiver knows the secret, it can verify that the webhook request is coming from us. And then on line 9, we start the HTTP client. We do a post request. We pass the URL. We pass the body. We pass the headers. And then the most important thing that we do is on line 16, where we check the status code, and if it's above 300, we raise an error. This is really important because probably if you're doing webhook request, you're doing webhook request through a task manager. You can think about Celery, you can think about Dramatic, you can think about RQ, you can think about Arc. So these are all task managers that you can use to make webhook request. And it's extremely important to fail in a proper way because you want to communicate to the task manager that your task failed, because you want to set a retry policy in place. And if we talk about incoming webhook, well, they're pretty much an API endpoint. Here again, we're using the async syntax, but an implementation with Flask will be pretty much the same. So here we are receiving the request. We convert the body of the request to JSON, and then we process the data. And depending on the result, we either return a KO response or no KO response with a different status code. So this is pretty much the simplest implementation that you can have for an incoming webhook. And there are a few things that we can really improve, and actually we should improve, especially from the security perspective. So here you can find a better implementation of an incoming webhook. So first of all, we don't try to convert directly the body to a JSON, but we just read the body. And then on line 4, we do something. We verify the IP address of the request. This is not always possible because the origin, the IP address of the request is not always known beforehand. It really depends on the provider, on the API providers. But if you know, if the provider, like for example, if GitHub shares the IP address, the pool of IP address that they use for webhooks, then it's a good thing to verify that the webhook is coming from this IP address. And then we do another thing on line 8, which is verify the signature. So again, we know the secret because it's shared between us and between the maker of the webhook. And then we can verify the signature inside the header that is the same. So we receive the webhook, we check, we read the payload, and then we create an encryption version of the payload using the secret. And then we verify whether this encrypted version matches with the one inside the header. In case the verify IP fails or the verify signature fails, we raise an error. Otherwise, we proceed with the with line 17, where we process the data, and if everything works correctly, we return an OK message. Otherwise, we return a status code 400. And if we dig a little bit more inside implementation, these are the three different functions that we call. We call verify IP and verify signature inside incoming webhook, and we call the make signature from the outgoing webhook. So verify IP is fairly simple. We have a tuple, and can be a tuple, can be a list, can be any iterable. We have a list of IP addresses, and we check whether the IP address of the request is one of them. With make signature, we pass a secret, we pass a body. We use HMAC, which is a library from the standard library, and we calculate the encrypted version. And inside verify signature, we do the opposite. So we create a signature, and then we compare that the signature received and the signature that we just created, they match. And this is pretty much all about webhooks. I think that both implementation, the outgoing and the incoming webhooks, they are pretty good starting point. But there are a few things that we need to consider apart from the code. And first, always use on both sides, like when you do request and when you receive requests, always use HTTPS. So on the outgoing webhook, like verify that you're calling an HTTPS endpoint, and fail if the certification verification is if the certificate verification fails. This is like a parameter that you can set inside the client. In my case, it was by default. So in case the certificate verification fails, the client request will fail. And on the outgoing, on the incoming webhooks, just put your server behind a load balancer with the certificate. Another thing is favor random endpoint, especially for the incoming webhooks. This is especially important for like if you have multiple webhooks and if you're receiving webhooks from different services. Another thing is to fail fast. So most incoming webhooks have a timeout. For example, GitHub has a 10 seconds timeout. So you need to return a response before the end of the timeout. Otherwise, even if you return a response, they will consider your webhook as failed. The other thing is try, when it's possible, try to verify IP addresses. Always verify the signature. That's pretty much a standard. And you can use the the timestamp to check the age of the webhook. This is important because there might be cases in which someone is performing a reply attack. So they are somehow they got the payload, and now they are just repeating the HTTP request with the payload, and like the webhook will succeed because the signature is still valid. There's no like a timestamp inside the signature, but something that you can do is to verify the age of the timestamp. So if the webhook is too old, then probably something bad happened behind. So you can use the timestamp to get it to the signature to verify whether you should trust the incoming webhook or not. The other thing that you should do, both on the outgoing and incoming webhook, is to specify an ID or to check the ID when you receive it. This is because you probably want to implement idempotent webhooks. So you don't want to receive a request multiple times, or if you receive a webhook multiple times, you want to skip it in case. And from the outgoing webhook perspective, you want to give the chance to the receiver to say, okay, I already received this webhook. There are a couple more things that we want to check. And like I said, you probably want to use a task manager to run your outgoing webhooks. You can think about Celery, you can think about Arcu, you can think about Dramatic, you can think about Hark if you want to say on the async.io side. Something that probably you want to implement for the webhook retries is the exponential backoff. So you want to wait an exponential time between each retry. The other thing is that probably you want to put a limit on the number of retries. Could be 3, can be multiple times during 2 days or 3 days. Another thing that you can do for the outgoing webhooks is to put your machines, so the machine that are going to perform the request, behind a net. And then you can have a single or like a pool of IP addresses that you can share with the receivers. And another important thing, especially if you're receiving, like if the user are putting the URL for the webhooks, is to sanitize the outgoing webhook. Because the URL can be an URL to your private VPC. So it's probably don't want to flood your internal services with webhook. So just double check all these things. And now we can talk about WebSockets. So WebSockets is something completely different compared to webhooks. So first of all, WebSocket is a standard in the sense that there is a protocol, there is a definition, there is a specification. There is the RFC 6455, which is it's the specification for the WebSockets. Like I said, it's bidirectional, so it's a low latency bidirectional channel of communication. There is a browser APIs, which is standardized by the W3C. So you can expect that the client side from the browser perspective should work pretty much the same on all the platform. And one important thing is that it's built on top of TCP, so it doesn't use HTTP, and this brings a lot of issues and different concerns. It supports port 80 for the normal WebSocket and port 4043 for the secure WebSocket, so there is also a secure version. It has a specific scheme, so it's WCS and WSS for the secure one. And it starts as an HTTP request, and then it gets upgraded. So this is how webhooks, a WebSocket request starts. So it starts with like a normal HTTP request, and then there is a connection upgrade, and there is a specification for upgrade to WebSocket. And then the server would reply with this response, which is connection upgrade, upgrade WebSocket, and that will be part of the payload of the response. Now, if we talk about WebSockets in Python, there are a few things that we need to consider. Well, Python is not an asynchronous language by default, so like out of the box, it's not super easy to implement, like either a WebSocket server or a WebSocket client in Python. There are a few things that we can consider. So we can use threads, we can use evenlet, or we can use async.im. So here is probably the simplest implementation for WebSocket endpoint, always using, in this case, async.io. This implementation is based on Starlet, which is an async.io web framework. We created this WebSocket endpoint. We have an argument called WebSocket. When we receive the request, we call WebSocket accept. So we accept the WebSocket request. And then what we can do on line 5, for example, we can send a message. On line 6, we can read the message. Then we have a while true just to send and read messages continuously. And then in case something happens, we can close the WebSocket. That's pretty much how you can implement a WebSocket endpoint using Starlet. And you can do the same with Django, with channels. So you need to use channels if you want to implement a WebSocket consumer. So the API is pretty much the same. So you have connect, you have accept, you need to accept the connection, then you can send messages. You cannot read, like you don't have self webhooks.read, but you need to specify a function. You need to specify a method, which is called when you receive messages. So you have the def receive, you have the text data, so you can read the messages that the user is sending, and then you can do different things. Like in this case, I'm sending the Pong message, and then again you can disconnect or you can do other things. So this is pretty much two different implementation, always using SyncIO or Django with channels. And implementation is fairly simple, I would say, because there is a lot of heavy lifting under the hood made by the framework. And there are a lot of tips that I can share on WebSockets. So the first thing is that it's a bare stateful protocol in the sense that like the specification is extremely useful, but it leaves you with a lot of work that you need to do. For example, if for any reason the connection is dropped between the server and the client doesn't reconnect automatically, and the server cannot do because the request needs to start from the client. So you need to implement inside the client that if the connection drops for any reason, it needs to restart. And this is not done by default. This is not done by the protocol, by the WebSocket specification. So it's a logic that you need to implement inside the client. Another thing is that if you need bidirectional communication between a mobile in general and server, consider your PC. The important thing is WebSocket doesn't support HTTP2. Like there is no specification to use WebSocket on HTTP2. So there is a draft open, but it's not a standard yet. So you cannot reuse many of the HTTP2 features. Another thing is try to leverage libraries on both the front end and the back end sides. Like again, there is a lot of heavy lifting made by libraries, especially on the client side, because the logic to handle WebSockets can be really complex. Another thing is that one WebSocket connection is one TCP connection, and 50 tabs are equal to 50 TCP connections, and there is no way to reduce this. Like I said before, WebSocket doesn't support HTTP2, so there is no way to multiplex multiple messages or multiple connection on one TCP connection. Another thing is, especially for clients, it's fundamental to have an exponential random backoff on client side for reconnection. So if you think you have like thousands of clients connected to your server, and for any reason the connection drops, the last thing that you want to have is to have all the clients trying to reconnect at the same time. So on your client library, you want to implement an exponential random backoff. So the clients are going to reconnect in the next 5 minutes, but they're going to try to reconnect at random time. And because WebSocket's a really bare protocol, authentication is hard. Like the API which are exposed inside the browsers, they don't give you the chance to specify headers. So you cannot change or you cannot pass a token directly. The thing that you can do is you can pass a token in the URL when you call the WebSocket, or you need to implement a protocol inside the messages. So you need to have both the client and the server aware that you're gonna send messages to authenticate each other. So the client can open a connection, then it's gonna send the token through the messages. The server is gonna check the message, it's gonna check the token, then it's gonna reply, okay, you're authenticated. Because these are things that by default the stateful the WebSocket protocol doesn't implement. And now I have a few goodbye tips. I want to start with security. So again, you use only HTTPS and WSS. So both the incoming and outgoing webhooks, put your server behind load balancer with certificate, and always verify the certificate of the endpoint that you're calling. And for the WebSockets, especially because if you're doing messaging, if you're doing chat, you're sending messages in plain if you're not using a secure WebSocket. So again, put your web server behind a load balancer with a certificate. The other thing is, if you can verify IP addresses, it's not always possible, but if you can, it's extremely useful. Always verify the signature. That's pretty much a standard, so it's something that it's always available. Try to use random unique URL for you incoming webhooks, and yeah, once again, verify SSL certificate on your outgoing webhooks. And on the scalability, I have again a few remarks. So use exponential random backup on the WebSocket clients. Use exponential, like random is not necessary, but for sure, like exponential backup is really useful on your outgoing webhooks. Set a timeout on your outgoing webhooks for the HTTP request. In my case, I didn't specify a timeout because by default it's 5 seconds. And for the streaming, for another thing that you consider, if you don't need like a bi-directional stream, like with the WebSocket, but you only need a stream from the server, something that you consider is SSE, server-side event, because it's compatible with HTTP2. So if you have a user with 50 tabs open, you're going to have only one TCP connection. And related to WebSocket, there are a few more things. First of all, if you're behind a load balancer, usually load balancer, they have a timeout of something that you can specify. Like with GCP, for example, it's 30 minutes. So you cannot have TCP connection longer than 30 minutes. Another thing is that WebSocket connection are TCP connections. So you cannot use an application load balancer. You cannot use an HTTP load balancer, but you need to use a TCP load balancer. Another thing is that you cannot, because the connection are stateful, you cannot really load balance connection. So as soon as a connection is open, the connection is there to stay. So these are a few things that you need to consider when you're building, especially when you're building WebSockets. Okay. Again, thanks for your time. Thanks for listening. If there is time, I'm happy to take questions. There is a link to the repository with the code. There is a working example when you can run your application. You can trigger webhooks, and you can start a WebSocket connection from the browser. And if you are interested in Python and DevOps topics, you can check PyBootcamp. Thank you.
Thank you, Christian. Excellent. It's not really introduction. It's more like an overview of a full course on webhooks and WebSockets. There are no questions posted yet. The YouTube stream is a bit later. Okay, here comes something. You recommended leveraging libraries for front-end and back-end. Can you recommend any that are simple to use, especially for front-end, for Python programmers with limited JavaScript skills? So could you recommend any leveraging libraries that are simple to use?
Can you hear me?
Sure, I guess YouTube also does here.
Cool. So on the front-end side, it really depends on your framework. If you're using React, there is probably something for WebSocket. If you're using GraphQL, there is another abstraction on top of GraphQL, which are subscription, which are using WebSocket. So it really depends on your front-end framework. Something that you could consider is using Socket.io, which is another abstraction on top of WebSockets with a completely different implementation, but uses Socket.io. So it's another one that you can consider. But you really need to find something, because WebSocket is just a protocol at the end. So the implementation of the messages, it really depends on both the client and the server. But yeah, check for something specific to your web framework.
So you start with a web framework, and then you start with the front end, and then you get something compatible with that.
Yeah, especially for WebSocket, that's probably the best way to go. Like I said during the talk, there are a lot of limitations on WebSocket. Duration of the stream, because maybe it's limited by the load balancer. So you also need to double check with AWS, GCP, or the provider that you're using.
Okay, thanks.
Welcome.
There are no more questions, and I guess we have to cut it here. But to all who is listening to us, or everybody who will be watching this on YouTube later, you are more than welcome to ask questions using Christian credentials and also Slack and the comments on YouTube.
Sure, I'll be around on the Slack channel. So,
fantastic. Thanks a lot. Thanks a lot for giving this talk. And I guess I'll see you around in Slack.
Cheers. Bye.
Cheers. Bye-bye.